Good morning, everyone. My name is Yijing Chen, and I am from the Universiti, Brunei, Darussalam. It is a great honor to be here today to share our insights and research on digital transformation and AI integration, which can Reimagining mathematics teacher education for the digital age. As you can see, the topic today focuses on the how digital transformation and artificial intelligence are reimagining the education of mathematics teachers. This is not merely a technological discussion. It is a profound issue concerning the future development of education. In this rapidly evolving digital era, the question of how we prepare mathematics teachers to adapt to and lead future educational landscapes presents a significant challenge. The deep integration of digital transformation and artificial intelligence is fundamentally reshaping the global educational landscape. This aligns perfectly with the United Nations Sustainable Development Goal 4, which equals to SDG 4, which aims to ensure inclusive and equitable quality education and promote lifelong learning opportunities for all. This paradigm shift necessitates a critical reevaluation of how we prepare educators, particularly in equipping them for increasingly virtualized and blended learning environments. And let's turn our attention to the diagram on the right. It clearly illustrates how digital learning technology serves as a central hub, radiating outwards to influence various facts of the educational system. Digital learning technologies are not just tools, they are powerful drivers impacting instructional modality, learner development, personnel and support services, partnerships, instructor development, and organizational policies and planning. This diagram underscores that digital transformation is a systematic endeavor requiring a multi-dimensional approach and investment to truly modernize education. However, while embracing technology, we must also be wary of techno-solutionism. This tendency often overemphasizes the adoption of tools at the expense of meaningful pedagogical renewal. If we merely focus on the tools themselves, technological integration risks remaining superficial and failing to unlock its true potential. Therefore, we advocate for a shift in mathematics teacher education from mere tool adoption to a more reflective and system-aware approach. This requires us to delve deeper into the intrinsic connection between technology and pedagogy. The diagram on the right provides a detailed depiction of the challenges AI faces in mathematics education and the corresponding pedagogical approaches. The upper section outlines AI integration challenges in mathematics education, which include conflict against deep learning, AI over-reliance, validity and integrity, teacher readiness, deep reasoning limits, equity and ethics, and the last one is discourse disruption. These challenges are not isolated, they are interconnected, forming a complex landscape for AI integration in education. The lower section presents AI pedagogical approaches in mathematics education, which include learning and conceptual understanding, adaptive and personalized learning, inquiry-driven pedagogy. The fourth one is teacher-mediated integration, and the final one is computational and multimodal practices. These pedagogical approaches are interconnected through a central mechanism, aiming to address the aforementioned challenges. The core idea of this diagram is that we must not solely focus on technology itself, but rather on how to effectively integrate AI into mathematics education through innovative pedagogy, thereby overcoming challenges and achieving genuine educational innovation. AI-driven analytics offer opportunities to teacher development. They not only provide personalized feedback, but also identify student learning patterns, helping teachers gain deeper insights into the learning process. By analyzing performances in simulated environments, AI analytics can support teachers in developing more adaptive pedagogical judgment. Let's examine the circular diagram on the right, which illustrates various applications of AI analytics in teacher development. The central part features different AI technologies such as adaptive AI, machine learning, learning platforms, chatbots, and text analysis. The outer rings provide specific application examples, including ChatGPT, AI chatbots, Google, Gemini, and Bard, and as well as AI assessment applications, AI teacher personalization tools. This diagram emphasizes that AI analytics is more than just grading students. It is a powerful tool that helps teachers identify weakness in their instruction, discover students' learning patterns, and optimize teaching strategies, and ultimately enhancing teaching effectiveness. It frees teachers from tedious data processing, allowing them to dedicate more energy to instructional innovation and personalized guidance. Moreover, immersive learning, particularly virtual simulation technology, provides teachers with a safe and highly effective platform for practice. By replicating complex classroom scenarios, teachers can practice various teaching techniques and strategies in an environment free from real-world risks. The message on the right vividly depicts a virtual classroom scene where we can see students actively engaged in learning. The advantage of such virtual environments is that they allow teachers to repeatedly experiment with different teaching methods, observe students' reactions in various contexts, and learn and grow from these experiences. For instance, generative AI enhanced virtual reality technology, such as teacher Gen AI, can provide computational linguistics analysis to further enrich this immersive experience. This means that teachers can practice teaching in a virtual environment and receive real-time feedback from AI so they can understand their performance in areas like verbal expression, questioning techniques, and classroom management. This model of safe trial and error and situational practice is crucial for training new teachers and enhancing the skills of existing educators in mathematics education. And the next slide presents one of the core arguments of our presentation today. The cultivation of adaptive pedagogical judgment is paramount. In the digital age, supporting future mathematics teachers in developing this judgment is essential to education. This requires teachers to critically evaluate and select digital tools, ensuring they align with specific learning objectives. We must move beyond the adoption for adoption's sake mentality that characterized techno-solutionism. Tools should serve pedagogy, not the other way around. So, the core training pillars on the right provide three critical dimensions for fostering this judgment. The first one is critical evaluation. Teachers need to be able to assess the applicability of AI applications in diverse student contexts. This means asking, is this AI tool truly suitable for my students? Can it help them learn better? Such questions can help teachers to evaluate it much more critically. And the second one is decision making. Teachers must integrate technological possibilities with sound pedagogical principles to make informed instructional decisions. This is not just about knowing how to use a tool, but knowing when, where, and why to use it. And the last one is goal alignment, ensuring that technology serves educational goals rather than educational goals adapting to technology. Our ultimate aim is to enhance students' learning outcome, not to showcase technological specifications. In summary, we should emphasize the teacher's professional judgment by cannot be replaced by any technology. We are not training tool operators, but rather intelligent educators who can harness technology to serve the essence of the education. So, in the digital age, promoting reflective practice and ethical AI use among teachers is equally crucial. Effective mathematics teachers' education must foster teachers' capacity for reflection. Educators need to critically evaluate the impact of AI-mediated platforms on students' learning and equity. This involves continuously assessing how digital affordance either bridge or widen the achievement gap in mathematics. We must ensure that technology does not become a new source of inequity, but rather promotes educational fairness. The ethical awareness section on the right highlights the importance of developing ethical awareness with complex AI ecosystems. Key areas of focus may include: the first one is identifying potential biases, especially in mathematics assessment. We must be aware about the potential of unfairness or discrimination introduced by such biases. The second one is ensuring rigorous data privacy standards, protecting students' personal data and learning privacy. The last one is promoting responsible use of generative AI tools, guiding teachers and students to use AI correctly and responsibly, avoiding misuse or abuse. So these two perspectives reminds us that technology is a double-edged sword, which means that while we enjoy its convenience, we must constantly be aware of the ethical challenges it may bring and actively seek solutions. So, reimagining teacher preparation is a process that leads to deep pedagogical transformation. Educators must be equipped to lead instruction in complex online-first educational contexts, moving beyond mere tech literacy. This triangle diagram can illustrate the three logical relationships in the digital transformation of teaching and learning in higher education. Although it is in higher education, but we can use it also in mathematics education. At the center is the digital transformation of teaching and learning with three vertices respecting The first one is value logic, which respects the fundamental values, goals, and vision of education. It guides and deepens pedagogical transformation. The one on the left is the technological logic. It represents digital technologies, tools, and platforms. It enhances and reshapes the teaching practices. And the one on the right is the practical logic. It represents actual teaching activities, classroom practices, and teacher experiences. It adapts and provides feedback and refine for instructional strategies. These three logics interact collectively, driving deep educational transformation. Value logic provides direction, technological logic can offer means, and practical logic tests effectiveness and provides feedback. Only through the organic combination of these three can true and sustainable pedagogical change can be achieved. So, as my presentation draws to a close, I would like to pose a few questions for your consideration and discussion. The first question is, how can we further bridge the gap between technological advancements and pedagogical innovation in teacher education? The second one is, what policies are needed to support ethical AI integration in mathematics classroom? These questions have no simple answers. They require the collective efforts of educators, policymakers, and technology developers to find the better solutions. So, let's cooperate to empower mathematics educators for the digital future. And this is my references. Thank you for all your kind attention. And I am now very happy to answer any questions you may have.